Hi, I'm an old guy and I do maths, and today we're looking at what might be the first in a couple of videos concerning lowest common multipliers when dealing with algebraic fractions. There's already a video in the playlists about fractions that only contain numerals. Algebraic fractions do cause some problems. Not when multiplying or dividing. There it's just a grind to get through it. But addition and subtraction, because of the rules of fractions, does usually cause some problems. So a problem, as you can see, is that neither of these fractions has the same. Neither of these sets of fractions, rather, has the same denominator. So let's start with this one. Now, the basic temptation, I guess, is to multiply the denominators so that you get a common denominator. And it is a common denominator, but it's not the lowest one. Why do we want the lowest one? Because smaller things are easier to deal with, I suppose, is the simple answer. But we can multiply 15 by 5 and we can get 75x. And we can multiply the top here by 5x and the top here by 15x, and we can tidy it up and we will get an answer. Far easier is, because 15 is a multiple of 5, leave this alone. Just work on this and say, what is it that we have to do to this to make that equal 15x? And the answer is multiply it by 3 over 3. So we get 3 on 15x from that, plus 1 on 15x, and that gives us 4 on 15x, and our story is at an end. Now, that is much better than trying to simplify something down from a fraction with a numerator of 75x. It saves time, it saves effort, it saves brain power. And once you get to my age, you're in favor of all of those things. Okay, now let's have a look at the second one. The first thing that I would do here is leave that alone and see if I can do something with this this denominator. So x squared minus 6x plus 5, which you will see I chose specifically, is equal to x minus 1, x minus 5. Okay, so let's rewrite what we've got, but with this factorized form as a numerator, as a denominator. Why can't I say denominator today? Okay, x minus 1, x minus 5. Right, now what we're going to do is we're absolutely not, going to multiply this into this. We do not want, if we can avoid it, to get a cubic as a denominator, because it's going to be murder to simplify. If we do this times this pair of expressions here, we have to multiply 2x by x minus 5 and 1 by x minus 1 times x minus 5, and then we have to try and simplify. It's much, much better to try and simplify at the start. So we're going to leave this alone, and we're going to do what we did up above. We're going to say, what do I have to do to this to get this? And the answer is multiply by x minus 1 over x minus 1. And you will see again that if you divide that, it's effectively 1. We are not disturbing the ratios at all. Okay, so what do we get? Well, what we get is we get a numerator of x minus 1, and we wind up with a common denominator, which is x minus 1, x minus 5. Because x minus 1 times x minus 5 gives us that. And from that we can subtract 2x. Not too bad. Not too bad. It could have been a lot worse. There could have been a cubic along here. There could have been a quadratic here and a quadratic here. unimaginable fun. You might have got somewhere by cancelling, but I can't see how. The problem being that we have a subtraction, not a multiplier up here. Okay, so what does that give us? Well, x minus 2x is negative x. So x minus 2x minus 1 over x minus 1 x minus 5. Don't be tempted to try and cancel that. It won't work. You can, if you want, express this as an expanded quadratic, in which case it would be x minus 1 minus 1, sorry, negative x minus 1 over x squared minus 6x plus 5. So take your pick. It's that or it's that. Both are perfectly valid answers. And I commend this method of doing things to you rather than what you might have dragged with you from primary school about simply multiplying the denominators. Okay, well, thank you for watching. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.